This is video on kinematics of particles. This is the 13th video in the series where we are looking at collision of particles. Now this video 3, we are particularly looking at collision of a particle with infinite mass. Okay, so let's see how does it look. Let's say I have a particle of mass m and I drop it from height h and it hits the ground. Now ground is infinite mass in comparison with this mass. So this is a case where this particle is having collision with the infinite mass. Now what happens is if we apply the momentum equation to this problem, we have to write m1u1 plus m2u2 is equal to m1v1 plus m2v2, where m1, m2 two particles and u are associated with initial velocity, symbol v is associated with final velocity. So if m2 is infinity, then this equation looks something terrible. You see, m2 is infinity, u2 initial velocity of ground is 0. Again m2 is infinity and final velocity of the ground is also going to be 0, because you are throwing an object on the ground, it's not going to move the ground. So initial and final velocity of the ground are 0. Now this equation becomes mathematically invalid with infinity into 0 equal to infinity into 0, etc. That's why we can't use this equation. Now let's look at the other equation. v2 minus v1 upon u2 minus e1 is minus e. Now you see v2 and u2 are going to be 0. Why? Because you are hitting something, hitting a ball on the ground. Ground is not going to move either before the impact or after the impact. So v2 and u2 are 0. So I put this, and finally, to cut the long story short, these two equations which we've been using for these like problems reduce to only one equation, which reads final velocity is initial velocity into coefficient of restitution, and this minus sign indicates that when you hit something towards infinite mass, is going to rebound. It's going to rebound. We're going to do a problem on this, but before that, one fact from physics. Let's master it. Let's say I have a particle here at a height h. When it falls down and reaches the second body, what has happened is it has this mgh, the potential energy is lost and gets converted into half mu square. In an ideal situation, if we assume there is no other loss of energy, then this mgh has to be equal to half mu square, telling us that u is equal to root 2 gh. So you see the height through which it falls and the velocity it achieves is related by this, u is equal to root 2 gh. A reverse situation, suppose from a ground I send up something with velocity u, then the initial kinetic energy is half mu square. When it reaches height h, its kinetic energy, this kinetic energy gets converted into potential energy, and equating the two again, you get u is equal to root 2 gh. These are simple things, but what I want to stress that it's handy to remember that this h and u, whether is falling from height h or going till height h, are related to each other by this u is equal to root 2 gh. And this should, while solving the problem, immediately it must flash in our mind, this relation. Now see, using this, we can look at one problem where I want to have this impact with infinite body n times. So let's say in first impact, body falls, it achieves u is equal to root 2 gh, and by our equation it goes back with v, goes up again, rebounces, V is equal to EU, or E is equal to, or V is equal to E root 2 GH. So final velocity of the first impact is E root 2 GH. Now it goes up, and when it comes down, it hits while in the second impact. So it goes up and comes down. In the second impact, it hits again with initial velocity of E is equal to root 2 GH, and goes back. If I use again the formula V is equal to EU, it goes back with E square root 2 GH. So what we find is, after second impact, it bounces with E square root 2 GH. Now if you keep extending this argument further, what you will find is, after nth impact, it bounces back with e raised to n root 2 GH, because when it hits the nth impact, its velocity is going to be e n minus 1 root 2 GH, and then it bounces back with v is equal to e raised to n root 2 GH. So a problem like this, suppose I drop a ball from a height of 50 meter. After 18th impact, what will its be bouncing velocity? Can easily be found by this formula. Put here the value of initial value of h, and put here the impact, the nth impact or 18th impact, 17th, whatever, and this will give you the bouncing velocity. So this is a very handy result. Now let's solve actual problem. It says a ball is dropped from a height of 9 meter from a horizontal upon a horizontal slab. If it rebounds to a height of 6 meter, show that the coefficient of restitution is 0.82. Okay, here is 9 meter. You're going to drop a ball from here. So when it reaches here in its first impact, we know that it achieves velocity of root 2 GH. H is 9, so 18g. Root 18g. Okay. Now with what velocity will it bounce back? Obviously E into U, and that is E into root 18g. So it starts moving up, but it reaches height of 6 only. Now we know from maybe second or third slide in this video that this h and this v are again related through root 2 gh. So root 2 into h, this 6, that is root 12ga. So this velocity, which was equal to e root 2 18g, is also equal to root 12g. And therefore equating these two, we can easily find value of e, which comes to 0.82. A simple problem really, but just to demonstrate as to how do you work on a situation where a finite body is having impact or collision with infinite mass. Thank you.